Hello. In this video, we'll be handling runtime errors. Now, the runtime errors differ from the parse errors or the lexer errors in so that whenever we encounter a runtime error, we want to stop the execution of the code. That was not the case with parse errors or the lexicon errors. Whenever we encountered a lexicon or a parse error, we set a flag and we continued parsing and we continued tokenizing. We only checked the flag before moving on to the next stage of the interpreter. That is for lexicon errors, the next stage would have been parsing, and for the parsing errors, the next stage would have been evaluation. So we only check the flag when we get to the next stage, but that will not be the case for runtime errors. Whenever we are interpreting the code, whenever we encounter a runtime error, we should stop the execution. And to do that, what we can do is simply throw an error in Java, and that will stop the code flow for me. So in this stage, we want to add support for handling runtime errors when evaluating the unary operator, that is minus. And you can read the book if you want to. I don't want to. If this were the code, it should throw an error that operand must be a number, and we should print the line number. We can only negate a number, not a string. So we need to handle that, and we can handle that in the interpreter class. So in our interpreter, we have this visit unary, where we visit the unary expression, and we have this case for the minus operator. This is where we need to add something. This is where we need to change. This is where we need to do the error handling. So what I need to do is, if the right instance of double, so if this is not the case, so if this is not the case, uh, then I want to throw an exception. But what exception am I going to throw? So we don't have that yet. We'll create it. So in our yeah, right here, we'll create a new class, interpreter exception, and it will be an exception. It will be a runtime exception, and in here we will have a public final token. Instead of token, you can store the line number if you want to. But if you can, why not just store the token number, the token itself? So let's create a constructor, add constructor. Okay, super message and this and this. I think that is fine for now. So that will be our interpreter exception. This is what we're going to throw here. New interpreter exception, and the message is going to be this operand must be a number, and the token is simply xpr dot operator. All right. We will be catching these exceptions in our interpret method. So control X, try. Oh, my bad, guys. Uh, control X, try. What we'll do is we'll catch the let's just make it interpreter exception, and instead of throwing it, I will print to the error output stream system dot error dot print line. I will print ex dot get message, and I will also print the line number like they want us to, and I can get that through token dot line, but not like this. I want to print it in the format they want us to. So that will be this line space, and from right here I will also return the exception. So if you're returning the exception, we need to handle that in our runner class. So if the result is instance of interpreter exception, in that case I want to exit out with the error code dot exit 70. Back to our interpreter class. Where is our unary? I think we're good. I think we can try to push it. Let me try that. Git add git commit -m. Let's see if it works. Okay, so something's wrong. Let's see what's wrong. This condition should have just been equal to. The parse error exception should be null. Only in that case should we continue with interpretation. So let's debug it now. And let's just go ahead, go ahead, go ahead, go ahead, go ahead, go ahead, go ahead. It does work. I think so. What did it print? Yeah, I think it works fine now. So you have to change this to a double equal to instead of a not equal to. Let's try to run it again. It's going to take a little time. Oh, it failed. World not equal to bar. Expected, no error. Test failed. So, test parsing expressions equality operator. And similarly, this parser exception, we're checking if it is null. If it is null, that is good. It should be null. So, my bad, guys. I made that mistake. So, let me try again. I hope it works. Let's see. It does work, I guess, this time. We can go to the next stage, and in the next stage we are handling binary operators, and we're going to be handling the star and the divide operator. So what we'll do is let's just copy this if from our interpreter, the unary if this, let's just copy it, get to binary. Where is it? Where is star? So the right should be an instance of double. If the right is not an instance of a double or the left is not an instance of a double, in that case we want to throw the error. Let's just make this left, and operands must be numbers. And similarly, and let's try to push it again. This also works. We can go to the next stage, and that is the plus and the minus operator. Now this is going to be a little different from the previous one. So the minus is simple, minus is quite literally the same thing. So let's just paste that here. Operands must be numbers. But for plus, uh, so in we can let me show you what they want from us. So previously what we were doing was, in this case I would typecast this to a string. In this case I would typecast 17 to a string, but that's not what they want us to do. They want us to throw an error in that case. So It should be an and. They both should be an instance of string. Only in that case do we concatenate them. If that is not the case, if left is an instance of string or right is an instance of string, in that case, we want to throw the error. And the error needs to be that both the operands must be numbers or strings. So you can throw this. Operands must be two numbers or two strings. That's the error they want us to throw. And I think that's it. Let's try to run it. 2 of 2. And what's the CQ1? This also works. Okay, now finally we get to the relational operators. Uh, it's again quite simple. We just need to check if they both are numbers and both the operands must be numbers. If that is not the case, we simply throw an error. So let me copy it and bring it here. In the interpreter, in the greater, they both must be in instance of double. Similarly, greater equal, less equal, and let's run it. This also works. We're good. So we completed this extension, the evaluating expressions, and we can now finally get to statements and state. So finally we get to something that will make our programming language more than a calculator. All right, so that's it for this video, and I'll see you in the next one.